Hello class. This next video, Basic Training Programming Concepts number 2. Earlier, I talked about that programming means the processing of numbers that represent values, conditions, states, etc. in the outside world. What do we mean by the outside world? Well, the outside world is the devices that are connected to the basic stamp. We'd like to call this the outside world because it's our world. It's the world that we live in. We live in the world of light. We live in the world of motion, temperature, length, current, humidity and force. This is our world. So we call it a physical measurement. Okay. However, the basic stamp microcontroller only understands one thing. It only understands voltage. So before the outside world can be represented in the microcontroller, it has to be changed into some type of voltage. Now that's what you've already done. You've already built circuits that changes the physical measurement into a voltage. And voltage come in many forms. It could be just a single, which means one, voltage level, like a 0 or a 1. Okay. Or you can have more than one wire connected to the microcontroller, and it can be a parallel group of wires. For example, if you have 4 wires connected to the microcontroller, then you can instruct the microcontroller to read those 4 wires together as a parallel group. And if it reads it as a group, then it has more options for the numbers. Also, voltages can change over time very fast, and we call that a wave. And you might get something like a pulse. And you can also, once again, whatever you do in single, you can also do in parallel. So you can have multiple wires sending pulse waves into it. And lastly, you can have communication signals. Same voltage levels, but the information that's coming into the microcontroller is very organized and grouped as bytes. And these bytes can be represent your name or an address or a telephone number, depending on how many bytes you need to represent all that information. Now there are several commands in the microcontroller that allows you to communicate with the outside world. The easiest command is simply using the in command for a particular port, for example, IN0, or for a group of ports, you can say INA, and INA means that it will read P0, P1, P2, and P3 all together as a single group, whereas IN0 will only read P0. And you can save that number into the variable that you have defined. So this is an example of a single voltage level that you're trying to measure. And you can use that for your motion sensors and maybe your push buttons. But for other objects such as your light sensors and temperature sensors and humidity sensors, you're going to need more powerful commands than the input command. RC time is useful for component circuits where you have either a variable resistor or a variable capacitor. If you have any one of these types of sensors, then you can use the RC time command to measure the value, and you can change this into a varying time, and that varying time could represent the different states of that sensor. If you're using an advanced device such as an analog to digital converter, this component does the job of changing an analog signal into a digital code that can be read by the microcontroller. And that code uses the shift in command to get that information. And the size of it is 8 bits. The one that we're using is 8 bits, but you can get other sizes. I believe in your project some of your air temperature components and maybe your current sensor components are using the analog to digital converter. Some of your components like your light sensor and your humidity sensor are using the RC time command, because the light sensor is just a varying resistance and the humidity sensor is just a varying capacitor. Now there is something called a photodiode that represents a current generator. And that current generator can also use the RC time command to input its changing value. Some of your devices, such as your GSM modem and your RFID reader, are very high-level input devices. So in order to communicate with these devices, you use the serial in command. The reason why is because these devices basically have a microcontroller on its device, and you're using two microcontrollers to communicate with each other. It's like two computers chatting, and they chat using serial communications. You learned this with Mr. Nabil about communications. So serial is one form of communicating between two devices. So you have to use a very, very advanced, powerful command called serial in to communicate and receive information. This is for your RFID components, and maybe if you're receiving a message from your GSM modem, you also use the serial in command to communicate with that component. In the next video, I'm going to talk more about the different signals and how we use the microcontroller to represent those signals. Thank you.